Hello everyone, this is Unit 2, Day 2. Okay, we're going to be evaluating functions and compositions. Okay, so it's important to keep some of those qualities of a function in mind. You know, the most important one is no repeating x values. Okay, but this lesson we're not going to talk about that one so much. We're just going to be evaluating functions and the composition of functions. Okay, so evaluate. All right, so it says evaluate f of x is equal to negative x squared plus 3 for x equals 2. Okay, so this word evaluate. It's just a fancy way of saying, hey, when our input is 2, what is our output? What happens when you plug a 2 in for your x? So that's all they're saying by evaluate. So just evaluate the function when x is equal to 2. Plug the function in, or plug the 2 in for anywhere you see an x. So you would write it like this. F of x is equal to, you'd have a negative 2 squared plus 3. Okay, so 2 squared is just 4. Add those two together and we get a negative 1. So what that is saying is when our input is 2, our output is negative 1. So input and our output. Okay? So all it means by evaluate. Wants to know what is the value of y when x is equal to 2. Okay. Let's move on to the next one. So the next one looks a little different in the sense that they actually just gave us a graph. Okay? And so first the question to ask is this graph a function? So we get at the vertical line test, and as you can see, we're only hitting the function once. So is this graph a function? Yes. You could either say no repeating x values or passes the vertical line test. Okay? So a couple different ways you can answer that, but in both cases mean the same thing. If it passes the vertical line test or you just put no repeating x values, that is what we are to assume. Okay. State the domain and range of the graph. All right. You can do that. So, as we go left to right, when we're doing the domain, as we go left to right, going this way, first x value I run into is this guy right here, when x is equal to 1. And I'm going to put that in the bracket because I certainly want to include that value. And as I continue on along the graph, I run into this little line right here that's pointing down. I draw the arrow there to signify that this thing is going down, down, down forever. All right, so therefore, as it approaches the right, we are approaching infinity. And then our range the range we start from the bottoms up. So as we come up here, the first thing we run into is this little line right over here off to the right. Okay, again, if you're using the pencil, you can just glide it right up the graph and you see you run into this thing first. All right, where's it pointing? Down, down, down. And so our range, we're going to start at negative infinity, but as we go up towards the top, where's our ceiling at? Right here. Okay, when y is equal to 3, we want to include that value. Okay? All right. So down here it says evaluate h of 2. What it wants to know, all right, is if I were to if this was actually a function, right, and my input was 2, what is my out, or I'm sorry, this is a function, but if there was an equation, right, you would, kind of did what we did up here. When x is equal to 2, we had to take this value and plug it in. We don't have that luxury here, okay? But it's still asking, when our input is 2, what is our output? Okay, so what is our y value when x is equal to 2? So we come over to 2, go up here, what do I run into? a 2. So we would just say h of 2 is 2. Right? Or the output when when your x value is 2 is 2. Okay? The next one, the next one kind of goes backwards a little bit. Okay, it says for what values of x is h of x equal to 3? Now remember, h of x is just a fancy way of saying y. So what values of x does our y equal 3? Okay, so we go up here to the top, and draw a line at 3, and how many times does our graph touch that line? Touches it twice. Well, what values though? Well, right here and right here, right? So when x is equal to 1, and when x is equal to 3. So both times, okay, our output is 3 when our input is 1 and 3. Let's go to example 3. Example 3, given the function h of x, evaluate the following. The process is still the same. Okay, so this is our input. It wants to know what our output is. So they give us the input. All right, and they want us to evaluate. Okay, so when our input is -1, what is our output? So we go down to -1. We go down, and as you can see, y is equal to -1. Let's go over when h is equal to 3. Okay, so I come down here, as you can see, that's right there. So when x is equal to 3, y is equal to -2. And now for the million-dollar question here, this is where students kind of mess up. What is the value of y when x is equal to 1? So we go over here to 1, and I see 2 points. So we have to decide which one's good and which one's not. Now this one has a hole in it. And if you remember inequalities from earlier in your math career, you remember that anytime we didn't want to include a value, we would put an open circle, and we wanted to include that value, we'd put a closed circle. Okay, so this is actually a continuous function, actually a continuous piecewise function, in the sense that even though down here we have a hole up top at 1 on the other graph, or the other equation that's being graphed here, okay, we have a closed circle here. So at 1, we don't want to say -1. We want to say when our input is 1, our output is actually 2. Okay? So just keep that in mind. Again, this is a piecewise function, which means we have 2 different functions being kind of tied into one picture here. And it has something to do with messing with domains, right? And so if you guys need some more elaborate, maybe elaborate on that more in class, just feel free to ask, okay? But anyway, that's a continuous piecewise function in the sense that no matter what you put in there for x, okay, all the values will be good. Even as we approach up here, right? This would be 9, 9, 9, 9, 9, 9, 9, right? But at 1, we go right back up here. So it continues on all the way through. Okay? For what values of h of x does our output equal -2? So this is a fancy way of saying y again, right? And so when y is equal to -2, I'm going to draw a line here. Where do I hit my graph? Again, that's why they always say values. So when x is equal to 0, and also when x is equal to 3. State the domain and range. Well, our domain here, it's a continuous function. It's starting way over to the left. It keeps going to the right, so our domain is -infinity to infinity. And our range, right, as we go from the bottoms up, you run into this arrow first, so we're pointing to -infinity, and again, it's heading towards positive infinity. All right, last page here. So we're moving on to compositions of functions. Okay, take a drink here real quick. Okay, so key points here right? We only have to simplify if it states simplest form. Okay, so what students will do, they'll get in the habit of simplifying things, right? And in this part, unless they tell you to, you don't have to. But what will happen is if you simplified this problem and got a wrong answer, you lose your points. Okay, so that's why it's highlighted here. It's in bold. Okay, only have to simplify if it states simplest form. Now, if you're feeling confident, go for it. Sometimes these expressions are easier than others, but just keep that in mind. So the first three, I'm not going to simplify because it doesn't tell me to, or first four. All right, so all I'm doing is I'm taking what value I have for f of x, what value I have for g of x, and then plugging it in anywhere I see that down here. So f of x is equal to 2x, g of x is equal to a negative x plus 1, and that's it. It doesn't say anything about simplest form, so I leave it like that. I go down below. Same process, except now I have a negative sign, so negative x plus 1. Okay, again, I'm not simplifying anything. Down here, 2x times a negative x plus 1. Again, I didn't simplify nothing. Didn't tell me to. And then here, 2x over negative x plus 1. And that is our function compositions, right? And all I'm doing is just taking whatever value we have for f of x, plugging it in there, and whatever value we have for g of x, plugging it in that guy. Okay. Now, as we continue on, though, not so lucky, right? Express 4a in simplest form. Okay, easy peasy. So we get 2x plus a negative x plus 1. Okay, so I don't have to add those parentheses anymore. So I get rid of the parentheses, and 2x minus x is just a regular x plus 1. All right, 4b in simplest form. Okay, 2x. Now we have a minus negative x plus 1. So I'm going to distribute that negative sign. So 2x plus x minus 1. Add those together. 3x. And then 1 goes by itself. Okay. Look at 4c. All right. 2x times negative x plus 1. Distribute. We get a negative 2x squared plus 2x. And we don't want to factor that again, right? So we just leave it as is. Okay. Now last group of problems here. In this case, right, they're giving us something different. They're actually giving us not a number, but actually expression. But the process is still the same. All right? So the difference between this guy here and this guy here is we're taking whatever we have for f of x, and we're substituting an a in there. So anywhere you see an x, put an a, and there's our answer. All right, let's go down to the next one. Same process, except now I want to take an a plus 2 and put it anywhere I see an x. So a plus 2 squared plus 5. And again, it doesn't say to simplify, so I leave it just like that. Okay, now the difference between c and a is that plus 2 comes outside of our function. So it's actually, whoops. So f of a plus 2 is, whoops, what do I keep doing here? Okay, a squared plus 5, right? Just like we had over here. And then we add 2. So we actually end up with a squared plus 7. Last one. Okay, so here we have a 2a, right? And here we have a 3a minus 1. Process is still the same. Anywhere you see an x, I replace it with a 2a. So I get 2a squared plus 5. Over here, I get a 3a minus 1 squared plus 5. Okay, so this one's not too bad to simplify. 4a squared plus 5. This one is going to involve a little bit of math. So let me write this off to the side here. So 3a minus 1, 3a minus 1. Okay, get the arrows in there. We get 9a squared minus 3a plus 1. So we get 9a squared minus 6a plus 1. So our answer, still not done here yet though, right? Because all I did was just find out what this guy is, right? So let me plug this guy back in. So it's going to be 9a squared minus 6a plus 1 plus 5. Okay, it says simplest form, so we're not quite done yet, okay? Just scrolling here. What's the problem? 9a squared minus 6a minus 6. I'm going to take out a 3. And voila. Okay. Rest it for homework, guys. Might seem like a lot. Everything but 11. We'll do 11 in class. But might seem like a lot, but not as time consuming as the last lesson. Okay? Good luck, you guys.